Hello guys, welcome again to my new video of 9 steps of hypothesis testing. As you have learned in previous video how to do hypothesis testing for proportional data. Now we are going to look at how to do hypothesis testing on mean data. So this example is about the paint factory. So it says that bucket of paint coming off of production line at ABC paint factory are labeled as containing 1 gallon. If the bucket typically contains different amount, then filling machine should be recalibrated. Here are the volumes in gallons from each 10 bucket samples of the production line: 1.01, 0.99, 1.00, 1.03, 1.01, 1.00, 0.98, 0.10, I mean 1.01, 1.00, 1.02. We have to test that does this data provide evidence at 10% significance level that the machine needs recalibration. Let's get into the doing the hypothesis testing. So step 1, determining the population parameter that's being tested. So here we are testing the mean, so we have to denote mean as a mu, like a Greek u. The mean volume, so parameter testing, so what we are testing here is the mean volume of paint being filled per bucket at the ABC factory paint factory production line. So step 2 is to state the null hypothesis. Is that mu is equal to 1. It says that there will be no difference in paint whatsoever, and we don't need to recalibrate the machine. Step 3 is to state the alternate hypothesis. It's denoted by H sub A. Mu is not equal to 1. So here we are given that every bucket has different amount. It doesn't say it's going to be equal. It doesn't say it's going to be less than 1 gallon or it's going to be greater than 1 gallon. So we got to use the not equal to sign here. As I mentioned in my previous video that there could be like three ways to write the alternate hypothesis. It's got to be either greater than, equal, not equal to, or less than the null hypothesis. So step 4 is the selecting the level of significance. That's most important thing because it's going to help us later down the road to decide whether to we reject null hypothesis or we fail to reject null hypothesis based on the significance level that we choose here. We don't need to choose significance level here because we have already given that we are gonna test uh, our evidence at 10% significance level. Step 5 to identify the test statistics is by using the formula of t-score is equal to sample mean minus hypothesized mean, that's this one, 1, or divided by standard deviation over square root of the number of success, that's gonna be 10. That we're gonna compute it later in step 7. So let's get to the step 6. That's important that we have to check that everything is normal. So since we have to do the normality test of x bar of the mean. So since our population is less than 30, we have to do the n times p sub 0 and n times n1 minus p sub 0, that both has to be greater than 10 or we fail to reject. We says that our data is not normally distributed. It has either left skew or right skewed distribution. So as we did the n, that's 10 times 1, that's hypothesized mean, the 1 it gives 10 obviously. So n times 1 minus p sub 0 is 10 times 1 minus 1, that gives us 0, which fails the normality test. So, and I also created this graph in JUMP to show that this data is not normally distributed and it's bit moderately or slightly left skewed, and since there is left skew in the distribution we cannot further proceed because the interval will not be accurate and it will give us like false information which could lead us to wrong answer. So we gotta stop right here for this test, and it cannot further pass. Thank you for watching this video.